Let's do a bunch of these factoring problems mixed up. One thing that we neglected on the previous page is that we should always look for a GCF first, right? That if our 2 or 3, depending on which problem we're on, terms have something in common, factor that out first. But x squared and 4 do not have anything in common. So how do we factor x squared plus 4? We could try some different things, but if you'll recall, what I said in the last video is a squared plus b squared is prime. If there's a plus sign in the middle, this doesn't work. So that means x squared plus 4 does not factor. It's prime. So you could try, if you wanted to try x plus 2 times x plus 2, go for it. But as soon as we start multiplying it out, hopefully we see, oh yeah, we get a middle term. We get a plus 2x and then another 2x, and they don't cancel. So we're not going to get, this binomial. We're going to get x squared plus 4x plus 4. So x squared plus 4 is prime. All right, well, part B is a subtraction. So we should be able to factor it. First, check for a GCF. 49 and 4 have nothing in common. So let's try to write it as something squared minus something else squared. Well, 49 is 7 squared. And then v squared is, v being squared. So 7v quantity squared makes 49v squared. And then 2 squared makes 4. Once we have it as a difference of 2 squares, as a subtraction, then it's 7v minus 2 times 7v plus 2. And you can definitely check it by foiling it. Even if it's just in your head, you sort of go, oh wait, the middle's gonna go cancel, because 7v times positive 2, negative 2 times 7v, we get plus 14v, negative 14v. That's why we don't get a middle term in this one. Nice. All right, part C. This one, it's to the 4th power. We've never factored anything in the 4th power, I don't think. But in this case, if it's 2 pieces and they're subtracted, it's probably something squared minus something else squared. So let's think about what squared would give us q to the 4th. I think it'd be q squared would be q to the 4th. And then 81 would be 9 squared. Okay, as soon as I get it as something squared minus something else squared, this a squared minus b squared, then I can just do q squared minus 9 times q squared plus 9. But here's the trick on this one. I can factor this first parenthesis again. The second parenthesis doesn't factor anymore because that plus sign, when it's a squared plus another squared, can't do anything with it. But this one is q minus 3 times q plus 3, because 3 times 3 makes 9. And by doing 1 positive, 1 negative, the middle will go away. But then the other q squared plus 9 is just part of our answer. So this is the final factored form. So it is possible to have 3 or even 4 or more parentheses in a factored form. Okay, that one's definitely more challenging. Hopefully that made sense. Let's try this next one. It's got 2 variables, but we can still handle it. We just need to think about what squared minus what else squared. If we're doing difference of 2 squareds, that's all we gotta worry about. So if I do x times t and square that whole thing, I would get x squared and t squared, so that works. And then 10 squared makes 100. So this should just be xt minus 10 times xt plus 10. Just like all the others, right? If in doubt, multiply it out. So you can FOIL and check that it works. All right. 2 is not a square number. That's the first thing I'm noticing. I'm supposed to get perfect squares. So especially if you see something that's not a perfect square, maybe think about a greatest common factor. Oh yeah, I should be factoring out a 2 as the first step, and it's not the second power, it's the 8th. So 2 times t to the 8th minus 25. Right? Now that I factored the 2 out, that greatest common factor, now it is a difference of 2 squares. To get the 8th power, that'd be t to the 4th squared, and then 5 squared. So what we get is the 2 is still in the answer. Don't neglect the greatest common factor out there. It's t to the 4th minus 5 times t to the 4th plus 5. Now, if 5 had been a perfect square, I would have needed to do this again. But we're not trying to have square roots in our factoring, so we don't need to keep going with this one. But I just want to make sure it's clear, like if this had been like 16 here, I would have had to do another factoring. But with 5, I can stop because nothing multiplies to 5 except 1 in itself. All right, in F, first thing I notice, a negative leading coefficient. I don't like that. We're going to definitely factor out a negative. And I think 16 divides 64. But you might want to double check that on a calculator. So when I divide both these by negative 16, I should get t squared minus 4. But again, feel free to double check on a calculator and notice when you multiply it out, you would get negative 16t squared and then positive 64. That's important because if this were a plus sign, I would have to stop there. But with a minus sign, we got to do a difference of 2 squares. So then it's t minus 2 times t plus 2. And the greatest common factor with negative 16 is still part of the answer. Nice. Last 2. First, check for greatest common factor. 9 is 3 times 3, but 3 doesn't go into these other 2 numbers. So no greatest common factor. We could do the AC method. We could do guess and check, but there are lots of things that multiply to 64. And 64 times 9 for the AC method, that's really large, and I don't have a calculator on me, so that's a mess. So instead, I am going to use some inference tools to think, well, maybe it's something squared, because I know 9 is 3 squared. Oh yeah, 64 is 8 squared. So it starts and ends in perfect squares. So we're really just checking, is the middle the minus 2ab? Or if I do 8y minus 3 times 8y minus 3, will I get to the negative 48? Notice I used negatives here because I knew I needed to add to a negative. I still am multiplying to a positive 9, but to add to a negative, we needed to make them both negative. All right, so we're doing guess and check, so we have to show a check. Let's try it. 8y times 8y is 64y squared. 8y times negative 3 is minus 24y. Negative 3 times 8y is negative 24y. And then negative 3 and negative 3 is positive 9. Yep, that gets us that middle term of negative 48y. So our factored form is 8y minus 3 and then quantity squared because it's the same factor twice. So that's what I mean about using guess and check for this. But you could also show that this middle is a times b times 2, or times negative 2 in this case. All right. I'm seeing perfect squares, but actually I'm also seeing a GCF. The greatest common factor here is 4. Let's get that out. All right? It's always going to be easier if we find that greatest common factor. Even though we could maybe factor it without it, the better answer is take out that greatest common factor first. So I'm dividing everything by 4. So I get 25y squared plus 10y plus 1. Now, this could be guess and check. This could be AC method. But I'm noticing, well, 25 is a perfect square. So 5y quantity squared makes 25y squared. And 1 squared makes 1. So let's just try 5y plus 1 times 5y plus 1. And then I'm going, after I check, make sure that 4 is in your answer, that greatest common factor. I'm not putting it in my check, but I need to put it in my answer. All right, let's do the FOIL. 5y times 5y, 25y squared. Then 5y times 1 is plus 5y. 1 times 5y is plus 5y. And 1 times 1 is plus 1. Well, that's looking like the 10y in the middle that we needed. Because we knew we were going to get the 25y squared and the plus 1. It was the middle that we're checking. So yep, it checks out. And that means the factored form is 5y plus 1 quantity squared. And that GCF of 4 is also in our answer.